Hello, my name is Veronica and welcome to my speed talk on the effect of an emerging fishery on a small African cyprinid fish in Lake Nabugabo, Uganda. Inland fisheries are vitally important for food security. However, many are at risk of overfishing. Fisheries are often size selective for the oldest and largest individuals in the stock. This can lead to phenotypic and sometimes evolutionary changes in fish populations, such as smaller size at maturity and increased reproductive output. However, there's still much we don't know about fisheries-induced change, in part because the majority of studies occur on temperate marine species or for fisheries that have been the target of commercial use for decades. Our study attempts to address this gap by providing some relatively rare insights into the first few years of a newly expanding Rastroniobola argentea fishery in the Lake Victoria Basin of East Africa. In this study, we focused on Lake Nabugabo, where we have been closely monitoring the fishery since its onset and intensification. We asked 3 research questions. First, how has the intensity and selectivity of the fishery changed? Second, has the abundance changed over the past decade? And lastly, have there been changes in the life history traits of R. argentea? Using a mixture of experimental gillnet data, fisher's catch assessments, and dissections, we got the following results. First, between 2016 and 2019, we found that the fishing effort has increased. More fishers are targeting the species, and they're doing so more selectively and effectively. Then we looked at changes in abundance of R. argentea. Here we have the median number of fish caught in our experimental gillnets on the y-axis and year on the x-axis. We compared data from 2008-2009, which is when previous work was conducted, to new data from 2016 to 2019. Box and whisker plots are showing the median values of fish caught per year, and we can see that there's been a dramatic decline in the abundance of R. argentea. We also looked at the proportion of R. argentea in our experimental nets at 3 sample distances from the shore. We again compared 2008-2009 to 2016-2019, and we found that the proportion of R. argentea, here in red, in the experimental gillnets has decreased regardless of distance from the shore. Lastly, we also detected changes in some key life history traits. We found no significant change in the size and maturity between our 2 study periods, fecundity or clutch volume. However, we found significant differences in egg volume and ovary mass for some individuals. So what could be driving these observed changes in some life history traits? One possibility is that the dramatic decline in abundance has led to increased food availability for survivors and thus a reduction in interspecific competition. This could allow females to invest more energy into reproduction. However, given that the intensification of the fishery and declines in the abundance of R. argentea coinciding with these changes, we believe that fishing is the driving factor. Our study highlights the importance of systematic long-term monitoring, particularly for often neglected tropical fisheries. Thank you for the opportunity to share my research, and I would also like to thank my supervisors, Loren Chapman and Diana Sharp. Thank you.